Chapter 4.2, Area. Day 2, left and right sums or upper and lower sums. Now those two ideas are not the same thing, but they are tied. What we're going to do today is we're going to look at what we did yesterday with the sigma notation, and we're going to tie it together and see how we're going to begin to tie it together and see how we use it to find the area under a function, area under a curve. We're going to start by using left and right sums, which could be construed to be upper and lower sums. They're not tied together. Left isn't always upper, and right's not always lower. It could switch back and forth, but they're basically the same process. All right, so what we're going to do is we're going to take a curve, and we're going to find the area underneath it. So right here what we have is this curve. We want to find the area underneath it down to the x-axis. So we're going to look for the area of this figure. We're going to start by estimating it. In other words, you're not going to find the actual value right away. And we're going to estimate it by drawing rectangles. All right? So we're going to start, we're going to do two approximations. We're going to do 5 rectangles, and as you see, we're going to use equal widths. We're going to start our first approximation. We're going to use the right side of the rectangle to find the height. Hence, the right side, or what did I say? Right sum. We're going to find the right sum first. All right, so what we need to do is calculate each rectangle. So the area under the curve from 0 to 2, 0 being right here, 2 being right there, we're going to take each rectangle. The first rectangle, we can see they're all 2/5 wide. So the first rectangle will be 2/5 times its height, and its height from the right side is the value of the function, which by the way is negative x squared plus 5. The value of the function evaluated at 2/5. And I got a table right here. We can see the function evaluated at 2/5 is 4.84. So it'll be 2/5 times 4.84. Now each rectangle is 2/5 wide, so the next one will be 2/5. And if we use the right side of this one, the right side of this one is at 4/5, which is 0.8. So at 0.8, it's 4.36. So we got our 2 rectangles. We'll go 3 rectangles, 2/5 times the right side of the next one is 6/5, which is 1.2, 3.56. Excuse me. Plus 2/5 times the right side of the next one is 8/5, or 1.6, which is 2.44. Plus the width times the height. The last one, the height is 10/5, which a lot of us call 2. The value of the function at 2 is 1. All right? So we go through, we multiply all those out. All right. I'm just going to add up the numbers that are inside the parentheses, because they're all multiplied by 2/5. So add up all the inside parentheses, and then multiply by 2/5. It's like just factoring out the 2/5. So it'll be 4.84 plus 4.36 plus 3.56 plus 2.44 plus 1, all times 2/5, which we can see is 6.48. Now, as we look at this image, notice how all the rectangles we've drawn are underneath our parabola. This is called a lower sum. because it's lower than the actual value. We didn't find the actual value. We've got these areas right here that are hindering our finding the actual value. So we're lower than the actual value. It's called a lower sum. It's also called a right sum because we used the right side of our rectangles when finding the height. Now, you may be able to look at this and guess. If we were to find a left sum, we'd use the left sides of the rectangle. So we're going to do that now. We're going to find a left sum. The left sides will be right here. And we're going to build our left rectangles from the left side. All right? This left rectangle, you'll notice, is above the parabola we're finding the height or the area underneath. This is called an upper sum because it's above the area we're looking for. And then it's going to be above by whatever these little regions are. So we're going to be too big. And again, each of our rectangles is 2/5 wide. And we're going to use the left sides, mainly at 0, 2/5, 4/5, 6/5, and 8/5. So it'll be 2/5 times 5 plus 4.84 plus 4.36 plus 3.56 plus 2.44. So we got the width times the 5 left-hand heights. All right, as we calculate that out, basically we can use the formula from above. We just need to change the 1, which is a right-hand sum, and replace it with the left-hand sum from above. So we're using these same numbers, but we're getting rid of the 1 and replacing it with a 5. And when we do that, we get 8.08. Now, as you take a look, you can see this is an upper sum because it's above. Right here, 6.48 is a lower sum because it's below. It's also the right sum because we use the right side of the rectangle to estimate it. This is a left sum because we use the left-hand side of the rectangle to estimate it. The actual value will be somewhere in between. Now, it's not exactly in between because this area, or this region, is curved. All right? So let's do one more example. All right, find the upper and lower sum for the region bounded by the graph of f of x equals x squared between 0 and 2. Do a quick sketch. I already have a table of values there. All right, so between 0 and 2, that's 0, that's 2, I want to draw some rectangles. All right, and I have decided to draw 4 rectangles. It doesn't matter how many you draw. Obviously, the more you use, the more accurate your answer will be. All right, so I'm going to start with the left-hand rectangles. So these will be my left-hand rectangles. All right, each of them is half a unit wide. And the first left-hand rectangle is 0 high plus the next one is 0.25 high. The next one is 1 high, and then is 1.5 high. 2.25 high. Sorry about that. And then we'll use that to estimate it. So it'll be 0.5 times 0 plus 0.25. Whoops. Plus 1 plus 2.25. So our estimate here is 1.75. That is a left-hand estimate. And we also can see, because our rectangles are underneath, it is a lower sum. All right, let's do the same problem. Now let's do a right-hand sum. All right, same graph. Going from 0 to 2, using 4 rectangles. This time, however, we're going to go from the right side. And as you can see, this will be an upper sum. Our width is still 1/2 each time, but now from the right side of the first rectangle is 0.25. The right side of the second is 1. The right side of the third is 2.25, and the right side of the last one is 4. So as we use those values to estimate it, the right-hand sum or the upper sum, because we're above, we'll go 0.5. Actually, we can use the same one before. We just need to add 4 to it, because we're getting rid of the 0 from the left, replacing it with the 4 from the right, and we get 3.75. So the estimate, the right-hand sum estimate, or the upper estimate, the upper sum is 3.75. So the actual value lies somewhere between 3.75 and 1.75, and to get that, you'll just use more rectangles. All right, a quick graphic example. We're just going to do the upper sums here. Now to get the upper sums, we're going to use 5 rectangles here. To get the upper sums, we're going to use the left side, because that'll give us rectangles above it. So we're going to do our upper sum estimates. Using those 5 rectangles. They are each 1 unit wide. The first one is 5 high. The next one is 2 high. The next one looks like 1.1 high. The next one looks like 0.6 high. And then it looks like 0.4 high. Again, this is just an estimate. Double estimate, because we're estimating from the graph too. So as we do this, we'll calculate. 5 plus 2 is 7. 1.1 is 8.1. Plus 0.6 plus 4 is 9.1. So the approximate area here is 9.1. If we're using the left-hand sum, which we're not going to do, if we're using the left-hand sum, we would go with the purple rectangles here. I'm sorry, if we'd go with the right-hand sum, we'd use these purple rectangles here. And our estimate would be under the actual value. So in review, to estimate area under a function, you're going to use left and right rectangles, which will give us a sum that's either above the actual value or below it, depending on the curve of the graph.